Yeah, sure. All right. So, I wish I could ask you guys for answers, but good news, I'll be back not next week, but right after that, so I can start asking you questions personally. And we're going to be doing a lot of multiple choice, and I'm going to be doing a lot of thumbs up, thumbs down kind of stuff, just so I can see how the heck you're doing. So the first question is, did you get the domain and range correct for number one? Thumbs up, thumbs down. Awesome. And that if you did not, here's the deal. If you don't understand something, it is on you to email me. I don't get this. I need a personal video. I need you to find me a video on YouTube. I need you to explain because this is up to you. I can't tell what you're thinking. All right, but if you got it right, great. Did you get the second one right? Thumbs up, thumbs down. Okay. And by the way, sometimes if a whole class goes thumbs down, it means I made a mistake. I made a mistake first period on a long problem, so it was goofy. I'll show you why. Um, so number three was should have been kind of easy. That was 0, 0. Those are my favorites. Thumbs up if you got it right. We good? Okay. Okay, mostly good. Hang on, I need to see everybody if at all possible. It's going to miraculously let me do that. I hope so. All right, and in the last one, hold up fingers. 1 for A, 2 for B, 3 for C, 4 for D. Okay. I got some tentative answers. All right, let's see what we got here. The answer was 2 for B. Very nice. Be aware there is a negative there. You got to watch out for that because sometimes the font is bad. That is a negative, and so it had to be flipped. So it absolutely could not be A or D. And the question was, where did it start? It started at +4. They both start at +4, but the Y started at 0. There you go. It was B. All right. I okay. I moved the other stuff later. Okay, good. So word problems. Yay. Read the problem and we'll talk about it. I will talk about it in a second. Just read it. Okay. A couple of things. Um, okay, good. A couple of things. In a couple of years, 2, 3, or 4 years, for some of you, you will be freshmen in college. And some of you, because you're math people, might take some serious science. Some of you may take physics in high school. I hear we have a great physics teacher. Um, so you would actually see this is a real life physics problem. It is a real thing. And that is it's pretty cool, actually. I really like physics. I mean, if anybody shoots pool, it's all physics, it's angles and spin and things like that. Couple of things I want to say is centripetal really is a thing. I know you've heard the word centrifugal. This is different. Centripetal is when you have a motion going in a circular path. There is actually a force trying to pull it inward. It can't go inward because there's forces pulling it outward. And for a visual, true story, my brother Michael, who lives in Florida, he's a really cool guy, taught me about centripetal force by tying a string on the tail of the cat and turning around in a circle. And the cat was like, wah, wah. It was pretty funny. You had to be there. But the point is that on the string, there are forces. There's the cat pulling out, and then there's the centripetal acceleration pulling in. And that is acceleration is always in the same units in English units, which we use because we're ridiculous. It's in feet per second squared. But in metric units, which the rest of the planet uses, it's always meters per second squared. So the velocity of the cat in that direction is sorry. I had a good childhood, it was fun. Is going to be defined by this equation. And you're going to make a graph of this equation. So for your purposes, okay, you basically I would make it X and Y. I would totally go because my calculator is in X and Y. So I would totally just from my own mind go like this. Okay. Now, please take out your calculators, which is a weird thing to say because they're on your computer, and graph this equation. Okay. So put that in your graphing window, and what you really have is a radical function, which you've been working at, and we know that y starts at 0 and x starts at 0, so that's easy enough, right? I know that my hk point is going to be at 0, 0, and it's going to be the square root of 2x, and when you graph it, you can look at the table, hit second graph, and that'll give you the table, which will look like this. So you graph it, and you get a table of values, and you've got a graph. That's easy enough. That's all you had to do. And if I asked you to sketch it on a test, you would, like, using your best drawing ability, sketch it for me. And because you're an overachiever, you would tell me this is what the graph is, like it says over there, okay? Now, be aware a couple of things. These are, you put in easy numbers, you get out numbers. That's, if the acceleration is this, the velocity is that. Ooh. And I did want to say that the square root of 2, I've told you this before, but square root of 2 is Valentine's Day, February 14th, and the square root of 3 is St. Patrick's Day, March 17th. So this is, the square root of 2 comes up a lot later on. It's a big fancy number, and we use it a lot later, but not today. So they could ask you to graph it, or they could, the other thing they do with word problems all the time is give you a number and ask you to plug it in. I think I have to give you back the equation. Here's your equation. So you plug in. They give you a velocity of 4 meters per second. So you plug a 4 in for v, and you solve. So do it. Solve it. It's good practice. It's like doing push-ups. And that should correlate with what it says on your graph, which is 8 meters per second squared. So hopefully you guys got an answer. I see a couple of you looking at the screen. What you would do is you would square both sides. So you've got 16 equals 2a, and you would divide both sides by 2, and you would get 8 equals a. So I would know that when my velocity is 4 meters per second, my acceleration would be 8 meters per second squared. Piece, straightforward. Did I tell you guys that when my brother put the cat in the dryer with the poodle, with my Aunt Sharon's poodle? Did I tell you about that? Yes or no? Shake your heads. No. Okay. Who do you think was tougher? Thumbs up if you think it was the poodle, thumbs down if you think it was the cat. You're right. The cat was much tougher. The poodle came running up the stairs. The cat came up later like a real, just like strutting up like, how dare you. My brother was trying to figure out who was tougher. My brother was a fun guy. So anyway, here's another one. What are you going to do if you get a question like this? I will give you a moment to figure it out, and then we'll discuss it. And if you can get an answer, let me know. If anybody gets an answer, hold up fingers. I am putting my work on the board as we speak. That is correct. Marco, nice. That is correct, Shirley. Thank you. Nice. Yes, Devin, that is also correct. Yes, Rachel. All right. Yes. Bunch of you getting it now. Yes. Nice. And the answer is A. And I want you to look at this. I wrote it out here, but like the cube root of 1,000, you kind of should know is 10 anyway, so that would be A. You don't even actually have to plug it in. But if you were to plug it in, you would get that. Here's the steps. If you're just, and ignore that, there's just some weird random mark on the screen. This is the regular steps you would do. I hope you did those. Divide both sides by the constant and take the square root of both, or yeah, take the square root. I'm sorry, square both sides to get rid of the radicals and take the cube root of both sides to solve. And that's important. What I wanted to do here also, because this is where we're going in a couple of minutes, is all right, what I have here is I'm going to take it from this step. I've got 31.915. I was being cubed with the exponents. Equals the square root of a cubed. And what I want you to pay a lot of attention to is that y'all should know that the square root of x really equals x to the 1/2 power. Because there's an invisible 2 over here, because the 1th root of anything would be meaningless. So if I take a square root, it's an invisible 2, and there's an invisible 1 here. And by definition, x to the a, the bth root of x to the a really equals x to the a over b. Outside dog goes underneath, inside dog is the doghouse. And by the way, just for the sake of completion, you can also write it, you can also write it like this, with the a on the outside, because order doesn't matter for exponents. Exponents and radicals are on the same level, you know, exponents and radicals, then multiplication, division, then addition, subtraction, like that. So they're the same level. So it doesn't matter if the a is on the outside of the parentheses or in the side, blah, blah. Anyway, you've got a fractional exponent, which I meant to review with you guys, but have not. So I wanted to do it here. So given that there's an invisible 2 here, I can really write that 31.915 as equal to a to the 3 over 2. And I would do that only for the sake of, I could solve it faster, because what I could do is clear the exponent by multiplying, because this will give me a 1, this will give me just a on that side. And then I can just put this in my calculator, and I would write it in my calculator as 31.915 to the, and I must use parentheses with a fractional exponent. This is your caret button, which tells it it's an exponent. And I would just say 2/3. 2 divided by 3. So if you type it in like that, you get the same answer. Please try to be comfortable with that. It's going to be useful. Fractional exponents are a lot faster than doing it in piecemeal, and they will come up quite a bit in the future. All right. I hate to do this, but for the sake of completion, I'm going to. I hate to do it because it's one of those little side trails that we really don't go down very often. But you should see it. So back in the day, do you remember when you did systems? And at first, when you were doing systems, you would find a solution and it would be like this. That would be systems of equalities. And then sooner or later, they made you do systems of inequalities. This is not a notation. I just wrote it. And you would get that one and say it's less than that. And you would get the other one and say it's greater than that. And your answer would be where they intersected that. Do you remember that? Nod your heads if you kind of remember doing. Yeah, yeah. All right. Well, this is a lot easier than that. All we're doing is one of the lines with a greater than or equal to, or greater than or less than. So that's that. But it's the same radical thing that we've been doing for the past 2 days. So you would actually graph it as you would pretend it was the equal sign. That's how we always graph these things anyway. Just pretend it's equals, and then you ask yourself a couple of questions. It would be a dotted line, the boundary line, because this is a greater than, not a greater than or equals to. If it was a greater than or equals to, it would be a solid line, but this one's a dotted line. And we know that it goes over -5/3, and then it stays at y equals 0. So there we go. You've got it. And the only other question you have to ask yourself is, am I shading up or am I shading down? And if you recall, some people are really comfortable with, oh, greater than, I shade up. Sometimes I mess that up, so I like to plug in a point. I like to plug in 0, 0 just to see if it's true. If 0, 0 is true, I color the piece that has 0, 0 in it. If 0, 0 is false, it gets no color, and I color the piece it's not in. So if I plug in x equals 0 and y equals 0 into my equation here, my original equation, y equals 0 right there, x equals 0 right there, I ask myself, is this true? And I solve it. And I say it is not true because 0 is not greater than the square root of 5. Therefore, 0 does not get color. And I shade up. It's on the next slide. Oh, it's on this slide. My bad. So there it is. So that's all you have to do. Thumbs up. You could probably do it if you had a little practice. Thumbs down. What the heck are you talking about, Ms. Betty? All right. Thank you. We're good-ish. So here's one. Go ahead. See what you get. Hold up fingers when you get an answer. That is correct. Who is that intrepid soul? Tyler Ross, you are correct. Devin, you're correct. Shirley, you're correct. Rachel, you're correct. Your little finger was off the screen. Yes, Marco, you are correct, but I saw it finally. Yes, Olivia, everybody's got it. Thank you. Yes, not everybody, but everybody that I saw that got it right. So the answer was D as in David. And the way that I would do this is I would end up with -2 because 2x plus 4 has to be greater than 0. So I would end up with the -2. So which answer choices can I kill? I can kill C. What is that yellow? Is obnoxious? I think it is. I'm going to kill C is dead. And I'm going to kill B because neither of them starts at -2. So it has to be A or D. And then obviously the difference between the two is, do I color up or color down? And if I plugged in 0, 0, I cannot live with that yellow. I can't see it. If I plugged in 0, 0, I would have 0 is greater than the square root of 0 plus 4. Is that true? It is not true because 0 is not greater than 2. Therefore, 0, 0 gets no color, and the answer is D. All right, so one more, I believe. All right, now you've got two problems coming up. I'm going to give you 4 minutes, but I need to say this. First of all, you're going to do number 5, and I'm going to ask you how you did. Number 6 is going to be important because you guys are really, really used to me giving you steps, giving you a formula, telling you what to do. Unfortunately for you, next year is going to start out really ugly if that's how you work, because the difference between Algebra 2 honors and pre-calculus honors is they expect you to be able to face stuff without direction and figure out yourself what to do. So I've got two choices. I can hurt you here, or I can send you next door and let you get hurt there. So being an honorable soul, I'm going to start giving you stuff that you don't know how to do, but you can do because there's only one thing that can be done. So go. Sorry, I talked a lot, but yeah, get it done. Do something. Do anything mathematically you can. Fight for it. I'll give you 4 minutes, I think, from now. All right, for starters, and I'll give you a couple more minutes on number 6. Did anybody get an answer for number 5? Hold up fingers if you've got an answer. Okay, Rachel, got you? I got to check if that's right. I believe it is. Nice. Anybody else? Not yet? Okay. Devin, I think you went the wrong way on shading. Check your shading. Okay, Gia, hang on. All right, it is number 1A. It's a less than, and it's positive. So it would go up. If there'd been a negative here, it would be D. My bad. I thought it was D for a second, but it's not. It's positive, so it goes up. So the answer was A. Let me just do that real quick, all right? So we end up with X has to be greater than or equal to negative 3 over 4. At that point, you're going to kill nothing because they all start there. And we know that it's a positive graph, and a positive radical looks like this, so we can kill C and D. And then the only question is it greater than or less than? And if we plug in the point 0, 0, we can do that. 0, 0 is different on both graphs. So I've got 0 is less than the square root of 0 plus 3. So is 0 less than the square root of 3? It is. That is true. So 0 does get shaded, and the answer has to be A. All right. Does anybody have a clue where to start with number 6? Raise a hand if you do. I won't make you talk, I promise. But does anybody have, maybe give me a like this if you think maybe you might have an idea? Nobody? All right, shake your head no if you have no idea where to start, and that's okay. All right. So if I had a gun to your head in an alley, you're going to die. Is that correct? Okay. I will give you a hint. And I want you guys to be aware that you knew this. You guys do know that 3 is X and 6 is Y, right? Nod your heads like bobbles. We knew that. Sure we did. And you guys do see that there's an X and a Y there, yes? So, nod your head like bobbles if you know what to do now. Okay, do that. If you don't know what to do now, I will continue to beat it to death. We know that X equals 3 because they told us that. And we know that Y equals 6, and they gave us an equation with an X and a Y in it. So we can just plug in, and Y equals 6 equals 2. I know what I did wrong last time. Okay, square root of 3 plus B. Now, you got that written down. Do you know what to do next? Nod your heads if you know what to do next. Shake your head no if you have no earthly idea what to do next. It's okay if you don't. That's okay. All right, I'm going to rewrite it below here, and I'm going to say a couple of things about it, and I'm going to rewrite it so I can work on it. Here's the deal. You've got one equation with one variable. That can be solved. By the law, by definition, if you've got one equation and one letter, you can get that letter alone and get an answer. And once we've got an answer for B, I'll tell you what to do with it. So you will do math and you will solve. You'll divide both sides by 2. And you'll get 3 equals the square root of 3 plus b. And then we'll square both sides to get rid of that radical. And we'll get 9 equals 3 plus b. And then we'll subtract 3 from both sides. And we'll get b equals 6. All right, now, do you know what you're going to do with that b? Thumbs up if you've got an idea. If you see a place to put it. Thumbs down if you have no idea where that b is going to go. That's okay if you don't. If you do, go ahead and do something with it, all right? If you don't, let me show you. Because the question asks me which ordered pair, that means A, which flavor, A, B, C, or D, works with this graph. And I have a B, but I know B is a number, so I'll be working with this equation now. Y equals the square root of x plus 6. And one of these answer choices has to be true. So at that point, you're going to plug in the answer choices. And you should very quickly notice that A and B are going to give you silly answers. The square root of 6.5 is not going to be 2 or negative 2. So I can definitely kill A and B. Multiple choice is your friend. At that point, hold up fingers when you get an answer 3 or 4. Olivia, that is correct. Jack, that is correct. Shirley, that is correct. Tyler, that is correct. Marco, that is correct. Rachel, that is correct. Y'all good. Yeah, right? It's not that hard when you know what to do. The problem is going to be, will I give you this problem again? I'm not supposed to. That's the thing. We need to keep coming up with weird stuff so that you know. Here's the thing. There's always something you can do in a math problem. If it is solvable, there is always something, and you have to overcome your reluctance to try stuff. You have to, and particularly when you're going to take SATs, this is what they do all day long. I theoretically should start giving SAT problems. And I will. But you got to do something. Think of it as a knotted ball of yarn, and you have to find the end so you can start pulling it apart. You got to find a place to start. So that's your job. That's what we're going to be doing a lot of. All right. So the answer was D. All right, we're going to talk about nth roots. The time is 11:08 school time, probably. I'm guessing 11:07 people time. And time just changed. All right, so this will work. So let's talk about nth roots. Nth is a mathematical term that means some number I haven't quite gotten to yet. I didn't say that well, but like if I had a list of numbers, 1, 2, etc. And we know that somewhere at the end is infinity, there's all these numbers in between. So if I want to say use any one of those numbers between 1 and infinity, I'll say use the nth number, because I'm not going to say which one it is. I'm just going to say I'm going to use these numbers, the nth root. So the nth root means some number. You don't care about the standards, and you don't really care about then and now. I just leave those in. But I told you what the nth root means. And you know what a radical sign is by definition. Don't know why that's there. And an index. The index is a fancy word for the number on the outside. Or if it was a fractional exponent, the index would be the bottom, the denominator of your fraction. So there you go. And the radicand, I know I told you this, is the stuff under your radical. It's a fancy word for it. So there's your new vocabulary. Principal root, we're not going to care deeply about, but I will tell you that, let me start this. All right, if you have a positive, let's just do 2, an even number, you guys should become square root of 4. Nobody writes the 2. There's an invisible 2 there, so give me a second. Let's do 8. Oh, 64. Let's do 64. Let's do, I'm sorry. Let's do 81. I know 81 has a 4th root. All right, so if I was to do the 4th root of 81, I have to know that it's positive or negative. This will come up on the next slide. 3, they both work. Because -3 times -3 times -3 times -3 is positive 81. However, if I have an odd index, so here's an even index, and here's an odd index, the cube root of 64, for example, is only going to be the positive flavor because the cube root is very specific. But if I asked you what was the cube root of -64, it's going to be the negative one, because a negative times a negative times a negative is going to give me a negative. So if they're odd, it's very specific. If they're even, it's positive or negative, both work. You probably know that, but I don't know that you've ever had it written out. And this is just a fancy way of saying that this is really if it's I'm not going to write it again. It says that if something to the nth power is b, then the nth root of b is going to equal that something. That's all it's saying is do undo. And here's an example of it. -3 to the 4th power equals 81. Then the 4th root of 81 could be -3. And because somebody felt like it, they called the positive value the principal root. I will never test you on that. Don't worry about it. We know there's 2. And this is what this says, that there's 2. I just did all that in the last slide. So here's what we're doing today. We're going to get ugly, bloated radicans, and we're going to simplify them. If it says positive or negative in the beginning, for goodness sake, put positive and negative or put that symbol in front of your answer, because if it starts out with that, it's going to end with that. And I'm going to do it for you 2 ways, each one. There's the shortcut and it depends on how you think. I don't know which one you guys will like better, and I can't actually ask you. But one way to go is to think about this as a product. You've got the square root of 16 times the square root of that, and x to the fifth power. And square root of 16 is 4. And if you're to write this as a fractional exponent, remember there's an invisible 2 here. What you really have is x to the 8 over 2. So what we really have is 4x to the 4th. Another way to think about this is to be clear on the fact that 16x to the 8th really equals 4x to the 4th times 4x to the 4th, or 4x to the 4th squared. And then the square root of anything squared is itself. So you think about it whatever way makes you get the right answer. I'm good. All right, so that's your answer. Don't forget there was a positive or negative on the beginning. I do want to say this because I forgot to give you an example that makes it clear. But if I was to ask you to simplify positive or negative, please write this one down, 16x to the 9th power. It changes slightly. There's a 9 there, and it doesn't divide evenly by 2. So what you're going to have is positive negative square root of 16 times the square root of x to the 8th times the square root of x to the 1th, because x to the 8th times x to the 1th. I got a leftover, that's what I'm saying. So you got 4, don't lose your positive and negative. This is going to be x to the 8 over 2, and this is going to stay like that. I'm just going to leave it there. There's going to be a leftover. So my final answer is going to be radical x. That'll be that. So just be clear on that. If there's an odd number, I've got a leftover under the radical. You guys okay with this? Thumbs up if you're good, please. Thank you. Appreciate it. All right. If you're not good, it's okay. There will be, I'll post this, and I'll help you if you need it. So here's the next one. You can, if you got this, go ahead without me. Otherwise, you got to wait while I talk about it. I would like to write it as a fractional exponent. That's my preference, but you do you. And I'm not judging. So that should be my final answer. The other way to think about it is to be very clear on the fact that this really equals the square root of, you break it down into halves. That's a Q, not a G. So let me erase that because I have just effectively made it impossible to read. So there it is. And the square root of anything squared is itself. So there's your answer. Thumbs up if you got it right, please. Okay. Too easy? Do this one. Oh, just be aware you got a fifth root here, all right? So the fifth root of 243, I think I told you that already, but yeah. Times the fifth root of a to the 10th times the fifth root of b to the 15th, and that's 3. And I'll talk about that in a minute. A squared because it's 10 over 5, and b cubed because it's 15 over 5. All right? You're not responsible for higher roots because, frankly, you live in a world where calculators are ubiquitous, which is a word which means everywhere because they're on your cell phone. But it's not a bad thing to recognize some of them. So 3 to the first power we know is 3, and 3 squared we know is 9. 3 cubed we know is 27. 3 to the fourth is 9 times 9. 3 squared times 3 squared is 81. And if you were to multiply that times 3, you would get 3 to the fifth, which would be 243. All right? And 7 cubed is 343, which is just close enough that it messed me up for years. But again, you'll have calculators for everything. So you do it the way you do it. You should have gotten 3a squared b cubed. Thumbs up if you're good. Thumbs down if you're not. Okay. So the fifth root of 243 to the 10th b to the 15th is 3a squared b cubed. Yay. All right. This is just to remind you that I did not go away. We ignore it sometimes, but it's still a thing. We just can't graph it on our Cartesian coordinate plane, so it kind of gets left out a lot. But you should know that there is a positive and negative version, and your final answer has an I in it. It's the square root of positive 4 times the square root of negative 1, which would be I and 2, and it's positive and negative 2I. Please remember that didn't go away. All right? Hold up fingers for me if you get when you get an answer. That is correct, Rachel. Nice. Devin, that is correct. Gia, correct. Tyler, correct. Andrew, correct. Marco, Jack, correct. Shirley, correct. All right. Selena, correct. Yes, thank you. So, yeah, you guys get it. I forgot I got 2 Tylers and a son named Tyler. It's a very popular name. Go ahead. Should be able to do it without thinking now. Devin's correct. G is correct. Marco's correct. I'm sorry, that was not you. I'm sorry. I thought you were holding up a hand. I saw something behind your head. It's a piece of my poster. Never mind. Selena's correct. Jack's correct. Shirley's correct. We're good. All right. Rachel's correct. Marco's correct. Yes. Now I see. I thought you were using your left hand. If you look behind you, there's a poster with a yellow border. I just saw a piece of it. Never mind. All right. The answer is there. Okay. Stupid easy. Last one. Slight trick. Be careful. Okay. Be careful. It's only going to have a positive root because it's an odd index. That is correct, Gia. That is correct, Selena. That is careful. If you're holding up two fingers, you're telling me there's a negative root, and there is not. That is correct, Shirley. That is correct, Rachel. Yeah, it's only the positive one. There, if it's an odd index, it's going to be the same as the radicand. So there you go. Only the positive because the 32 is positive. And by the way, if I haven't told you this and you need to do like things squared, it's 2 to the first power is 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. You can do 2 to the 10th power without thinking very hard because it's just doubling every time. That's exponential growth on 2. All right. I'm sure I had a perfectly good reason for this example, but I cannot for the life of me recall what it was. So we know that that's 3x plus 2 to the 5th power. Third power. 15 divided by 5 is 3. There we go. So I hope you're okay. I'll give you a minute to write that one down just to be sure you're comfortable. All right. Just going to talk this one through. The cubed root of 27 is 3. So we're going to ignore those absolute value signs. And 9 divided by 3 is 3, so it should be B. And we're good. And I wanted to get to ugly word problems. What are you going to do? You're in an alley and a mugger throws a word problem at you and says, solve it or die. What are you going to do? And then I'm going to make you listen to something physics because it amuses me and interests me. And it won't kill you to hear it. Did Tyler go somewhere? Tyler Carl? Not far. Okay. Well, that does make you the example. I was wondering who to use for an example, so I will use you as my next example. All right. Physics again, and I hope you figured out basically that they told you energy is K, and they told you energy is K joules, and energy is 3.5 joules, so I can basically say K equals 3.5, and at that point, you're just plugging it into your calculator right here. Not hard, lots of words, no big deal, right? Actually, I find this one interesting because, think about it, a dust particle, well, you wouldn't think you could put a hole in stuff, but energy is a very cool thing. So what I wanted to tell you about is units, and as you get into more and more complicated math, units will save your life. They matter. So let me see here. Velocity is in meters per second. So if I was going to throw Tyler Carl off a building, or actually I'm going to drop him because I don't want to add extra velocity, he would be falling at a certain speed, but he is going to accelerate at the same exact rate as anybody else according to gravity on planet Earth. He's going to accelerate at 9.8 meters per second squared. That's meters per second, but now it's meters per second squared. Now, let me see who's. I'm guessing that Tyler Carl weighs more than Gia, and Gia would actually fall at exactly. If I dropped them both at the same time, they would both fall at exactly the same acceleration. They would both probably hit the ground at the same time because there's not enough wind resistance to make a difference. All right, but that's my acceleration. Now, there's something called newtons, which is the force they're going to hit the ground with. And Tyler Carl is going to hit the ground with a slightly bigger force than Gia is because he weighs more, because newtons are meters, or force is mass times acceleration. And if you weigh a little more, you're going to have a little bit bigger force. And energy is going to be meters squared times acceleration. So Tyler will have slightly more energy when he hits the ground. He will displace slightly more concrete than Gia would. I hope that makes sense. But the point is that energy is joules. And that's the amount of energy that you get from the force and a weight on that force. Anyway, it's all very cool. And if you take physics in high school or college, you might like it. Understand that you are given a value for K, and you're going to plug it in. Use a calculator to evaluate. So I hope you did, or that you're doing now, and that you get an answer, because it won't kill you to do the practice. And that is the cube root of 3.5. And if you're not comfortable, I'm hoping you're all comfortable putting that into the calculator now. I didn't queue up Rabbit, and I'm not going to, but I will tell you how I would type it in. It would say times 3.5. There is a cube root button, but I tend to use the, this is to the first power, to the 1 divided by 3. Times 3.5 to the 1/3 power minus, and frankly, I wouldn't bother to write the 0 if I was typing in a calculator. That's just me. But you probably should be better than I am. So 0.926 times 3.5 to the 1/3 power minus 1.69. So if you put it in your calculator, I got light issues. Not to mention the calculator's damaged, but right. It should look like that. There. So type in your calculator and see if you get an answer. It's so awkward. Have you got an answer yet? Nod your heads if you got an answer. No, yes? Maybe? Shake your heads no if you do not have an answer yet. Thank you. What time is it? I will queue up Wabbit for you, damn it. All right, I hope I'm not wasting your time. Maybe you guys are so great on this calculator that this is not useful to you, but I do think that that it's going to be your best friend pretty soon. 9. So we put that in, and I'm going to say times, and then I'm going to say 3.5. I have these parentheses there. You don't need them, but they won't kill you if you put them in. It doesn't hurt you at all. So I'll put them parentheses 3.5, and then the caret button says to the, and then I'm going to say 1/3 power, which is saying the cube root. And when I'm done with all that, I'm going to subtract, I'll be nice, 0.169. And if I did everything correctly, I get an answer. All right. Please be sure you can do things like that. Okay. So I probably want to kill that, and you can see it typed nicely. So there's your answer. So the hole created by a particle traveling with an energy of 3.5 joules will have a diameter of approximately 1.237, and what we got was close. Ah, the one I showed you on the calculator. There we go. 1.2369. All right. If you did want to check your work, which you should on a test, God knows on a test it matters. You should check your stuff. You would actually do the math and check to make sure that it worked out, and would get K is really, really close to 3.5. You lost some decimal places in the process. I'm not going to do this because it's the same problem, and they just changed K. No, okay, I'm sorry. They gave you D this time, 2.5. It says diameter equals 2.5. Here's your equation, and you need to solve for K. I believe you can. If you want the practice, it'll be on the slide with all the stuff. So yeah, you plug in D equals 2.5. You divide both sides by 0.926. No, you don't. You add first. You PEMDAS backwards. You add first, then you divide, then you cube both sides. Okay, and get an answer. So you can check your work. This is the one I wanted to do because this is also a real life physics problem. I literally saw my kid do it the other day. So what it is a pendulum. If you have, for some reason, something hanging from the ceiling and it's a ball and it swings back and forth, the pendulum will swing based on acceleration due to gravity. And this is your formula. And I'm asking you, looking at these words, can you get an answer? I'm going to give you 2 minutes, and then I'll start talking again. And you're out of here very soon because I'm ending 5 minutes early because it's Friday. Yeah, me. I am going to make you watch me do problem 6, which won't kill you. It might make you stronger. And this is it. It's Friday, last class. Yay. Did anybody get an answer? Okay, hold up fingers. What'd you get? Okay, okay, okay. The answer was indeed, drum roll, ladies and gentlemen, in your hearts, and we've got B. Two things. Gravity on planet Earth, this doesn't matter, but I'm going to tell you anyway. 30, that reminds me to be done. Gravity on planet Earth equals 32.2 feet per second squared. In English units, it's 9.81 in metric units. And if you do this, plug it into your calculator. Make sure you do the square root separately. Multiply it by 2. There is a pi button. Use your pi button. I'll bang it out real quick. I may not get time to do number 6 for you guys because I really did want to finish early. So we've got 2. Where the hell is your pi button? It's over the caret, right? So what we're going to do is 2 times second, there's your pi button, times the square root, and I'm going to fraction of 2 divided by 32, close parentheses, so it knows I'm all talking about the radical. And you should get 1.57. Make sure you can do that, okay? That's going to be the kind of thing you're going to have to be really, really good at. Defining your variables, it says 2 feet long, so that's L, and it says G equals 32, so they gave you everything you needed. How do I want to do this? All right, I'm going to make a video of number 6. If you don't, yeah, it's Friday. I want to get you out early. I know that some of you won't look at it, though, and that's killing me, but I'm going to make it anyway. So, for homework tonight, you've got 5 problems on Delta Math that are about the nth root. And if you get stuck, please watch the videos, all right? They're very good. And if you're still stuck after watching the videos, email me. I'll see if I can put you in the right direction. And you also have, I gave you the second 7 problems on your midterm review. I will post an answer key for the first 7 problems. I'm just giving you answers. So if you need to know how I got one of them, you got to ask me, okay? So if you have any questions, email me. Have a glorious weekend. I will be eating banana pudding for lunch. You guys have a great day. Wave at me before you go away. It'll make me happy. Have a great weekend. Thank you. Bye. Do your homework. Get smart. Be well.